welcome back to another episode of the DS30 podcast. My name is Ana Hocevar, and today I have the pleasure of being joined by Zach Glassman. He works as a data scientist, and today we are going to talk about data pipelines, everything in terms of operational stability of data pipelines, dealing with the complexity of data, and then also a little bit about how can we make outputs of data science projects useful to as many people as possible. So let's jump right in. Hello, Zach.
Hi, how are you?
Good. How are you? I'm so excited to have you talking to us today. I know you kind of well, I guess, but it would be nice if we sort of introduce you a little bit to our viewers. So, do you want to tell us just a little bit about your background and how you got into data science?
Sure. So I started off, I guess, working trying to be an academic, I guess, as an atomic physicist. I sort of learned along the way that I wasn't so enamored, I guess, with the physics part of it, but I really liked the data and the computers part of it. So I sort of decided to switch into data science. I did the data incubator fellowship and then eventually wound up working there for a while as well, and then subsequently moved to where I am today, where I work as sort of a data scientist, or you might call ML engineer, at a large asset manager.
Awesome. So today we thought we'd talk about data pipelines in particular, or for most of our time we have together. Maybe before we dive in with all the things that can go wrong with data pipelines, all the things that you've been thinking about, and all the kind of obstacles that are on the way, and things that are necessary to do to sort of have good data pipelines, I guess. Let's maybe first just define when we talk about data pipelines, what do you mean? What does that mean to you? And what does a data pipeline do? And sort of let's introduce our main topic first.
Yeah. So when I think about data pipelines, right, you you obviously should think about the purpose, and I think let's start with like an example. So let's say that I'm, working in a business and I want to generate like a dashboard, so like a plot of something or a set of plots of something. Um, Oftentimes it's the case that in order to make that plot, I have to get data from different places within my organization, or even perhaps from outside of my organization. And it is also often the case, unfortunately, maybe or fortunately, that this data is can be a little bit messy, and you may have to do some sort of transformation in order to make the data set sort of relevant for that plot, or maybe to enrich it in some way. So data pipelines are really any sort of operation that is moving or transforming or enriching data from any system to any system.
Great. So when you think about data pipelines, are there kind of any kind of main pillars of the things you need to have set up for the system to work well? Sort of, are there like big things that could go wrong, or anything that are, yeah, just kind of pillars of a good data pipeline?
Yeah, I mean, I think anything can go wrong, which is which is kind of the challenge. But I think I would say the biggest thing is you want to be very careful to understand when things go wrong, and that can be a little bit tricky. I'll give you kind of an example. So, like, let's say that you have a data pipeline that's running every day, right? And the data pipeline runs a query on like your source system, and it like pushes data into another system. Now, you may say, well, the thing runs as long as the query runs. And that's kind of one way of defining that it's working. Apologize for that. My cat is knocking things off tables. But another way that it could go wrong is if you find that one day your query doesn't return any data, and maybe your process doesn't fail, but if you're not measuring, say, the number of records that you're getting a day, right, you could also argue that your data pipeline is failing. And so I think it's a challenge because you have to switch from defining your success in terms of kind of like operational, did the program run, into discrete business metrics that are actually relevant to what you're trying to do. And it's often the case that defining those can be tricky. And but that's kind of the general thing you think about when you're implementing.
Hmm. So when you need to say know when it failed, right?
Mhm.
Um, do you have any sort of an example or any suggestions of how you can do that well, right? Or you mentioned basically that it can be difficult to know that, right? You can have a process where you can say, well, that failed, or no, actually, it's correct that it didn't return anything, or whatever. So maybe an example of when it's tricky to know when it failed and how you kind of go about tackling that. Does that make
Yeah,
sense?
yeah. So the I would say that the trickiest thing, the trickiest way to know that it's failing is when it sort of seems like it's working from an operational perspective, but it's producing, bad quality data. So I think the really key thing is within your data pipelines to measure the quality of your data. So a really simple example would be like if I have a data set that has a column that's like a really important identifier of that data set, or like what you might call a primary key. I might want to do a check to make sure that that isn't null. I might want to do a check that says that the number of records I get every day is roughly consistent, right? Because in certain cases, I might expect that. So these kind of checks, right, are good to perform. And then, typically you might set up some sort of system that if the check fails, might send you like a Slack message or an email message, or maybe alert some other team who needs to be involved. But having this kind of like measurement and then alerting is really important. And obviously, as like a data scientist, this sort of measurement and stuff is kind of typically what we would do on a data set anyway. So it's just kind of taking that and putting it into the automated pipeline.
Mhm. Great. And how much does that, in your opinion, or also in your experience, happen sort of as the pipeline matures, and how much can it happen ahead of time, right? How much can you get ready for all of such cases and all such checks as the pipeline is being set up first, and how much is that just a continuous process that you always have to keep doing?
I think it's sort of a two-part thing. You can set up the processes that enable this like ahead of time, right? So you can say that I'm going to have, if you think about a like a data pipeline as like a function, right? You can sort of write out a structure that says, okay, my data pipeline is going to extract data, it's going to transform data, it's going to perform data quality, and then it's going to load it somewhere. So you can kind of build those hooks, and you can build like this is how it's going to alert. But then when it comes to actually, defining these things that make it successful, that's kind of a continuous process because it depends on the usage sort of the data. And it may be the case that what's important to one consumer is not so important to another consumer. Like, you may have a case where you have a data set with 100 columns, and one person only uses 10 of them, they don't care about the others, and then suddenly some other person says, well, I really want to use this data too, and I want to use the other 90 columns. So now you have to care about those. So I think it's a continuous evolution, but you have to have a good foundation that enables you to easily iterate.
Hmm. And would you say there's any kind of big difference between a pipeline that is built for, say, delivering data for a dashboard versus data that will go into a machine learning model versus, I don't know, something else? Are there any fundamental differences there or not so much?
Um, I would say the only when are you talking? It depends if it's a model training or a model inference pipeline. Generally speaking, for reporting, and this isn't always the case, but oftentimes with dashboards, right, you're looking at kind of maybe a latest snapshot of the data, right? Or you're looking at like a Tableau report that's like, as of today, this is what my whatever plot I care about looks like. For ML pipelines, I would say most of the things remain the same. But the thing that you really want to be able to do with ML pipelines is to be able to kind of refresh the state. So, like if I'm training a model and my I want to be able to sort of reconstruct what my data was at the time I was training my model. And so, if you're not careful with your data pipelines, you can get yourself into a state where you don't actually have that data available at a later point in time.
Yeah,
Um,
that makes sense. Um, so in terms of we chatted a little bit before we started recording our podcast, and you also mentioned sort of the dealing with the complexity of data in data pipelines. Do you want to talk a little bit more about that? What are you thinking about in that sense?
Yeah, so uh, data is often complex, and I think one of there's a few there's like two types of complexity that I think about. One is like what I would consider inherent complexity, which I'll get to in a sec, but the other is complexity that comes from the state of the data. So that's things like, oftentimes you'll be working with data that has column names that you don't really know what they mean, and maybe they're not documented anywhere. And like it shouldn't be this way, but sometimes it is this way. And so the data might be complex because you have only a little bit of an understanding of the kind of full characteristics of the data. So that's kind of your, I would say, non-inherent complexity, and that just is just a practical reality that can happen. I would say more typically, what winds up happening is that if you're not maintaining really good metadata about your data, you might have a case where someone will like create some table that's specialized for a purpose that they care about, and if you don't know what that purpose was, like for example, maybe they filtered out some type of record in order to generate that table. And if you don't know that they did that filtering, if you're assuming that all the records are there, you could really mess up in a downstream pipeline. So that's kind of your complexity that's not related to the data itself, but related to like operations and maybe um, not having good metadata sometimes. And then the other thing is that there are many times where the data itself is complicated. Maybe it's low quality data, and that will complicate it. That can definitely happen. Um, Data will often have mistakes in it, right? And so that can, you may have a case where you're assuming that there's like a one-to-one mapping between two different data sets, but because one data set doesn't actually has like a duplicate record or something that you don't expect, it causes an issue. And then the other thing is that, especially with these automated feeds, like you're never really sure about what you're going to get. And there's people will, change schemas. They'll change assumptions about the data, and you need to be able to kind of quickly react to that if you can't sort of work around it in the first place. So those are all different ways it can be complicated.
Sounds like a nightmare indeed. But also just like that's the real world, right? The first thing that comes to mind to me when you're saying that is just how it relates back to the operational stability of things and just integrity of your data coming out, and what we were just talking about before, right? Just makes everything we were saying before that much more difficult, I guess. If yeah, you have all this inherent complexity, but then also just externally, maybe you don't even know what some column means and therefore what it should be and what should be happening with it, right?
Yeah. No, it's a little rough. I've gotten to the point where I kind of I almost operate on like a first failure, like a fast to fail principle, where like I'd rather things just fail quickly and then we can go fix them than to try and like handle every single case in the pipeline itself, which is just gets really nasty.
Hmm.
So
Yeah, I
um
was just going to ask that. So, how do you
yeah.
try to do this? Is there any approach or any tip or anything that you've tried and failed at, or tried and found that kind of an approach that works or makes sense?
I mean, one thing that's good is to have, as I said, like a good generic framework for doing things, because oftentimes, if you're building one data, if you only ever have to build one data pipeline, um, I guess congratulations, but also that's kind of unrealistic. Usually you have to build many. And oftentimes the same types of problems occur. So if you're building things in kind of a generic way, you might be able to solve some of these problems once and then have them be sort of percolated, which is good. I think again, right, the biggest thing you can do is really measure everything. So measure your data, profile your data like every time that you load. And for oftentimes it's looking at those profiles that can give you a lot of insights into what's going on. So for example, right, let's say you have a column of a data set you're loading that's kind of low cardinality, right? So it's like the set of things it can be is kind of small. um, One common way to do a data profile would be to say what are the distinct elements in this data set. And so if one day you notice that there's an extra type of element that's been added, that's a good hint that you might want to think about, ooh, is that going to affect anything? So I think the profiling and the measurement, I mean, I guess I used to be a scientist, so maybe measure is a cliche thing for scientists, but I think it really is the best way to solve these problems.
Hmm. I guess a word that comes to my mind is also kind of simulating, but maybe that's not what you're doing. But I'm thinking kind of where you could simulate different queries or different things that I guess could happen before they happen. Or do you have the luxury of just kind of rolling it out? We have this pipeline, then as we're using it, as you said before, we are letting it fail, and we learn from that, basically, right? What the complexity might be, or what the some non-stable operation we might have there is in our pipeline or something like that.
I guess we don't just or at least I try not to just deploy things that I know will fail. So usually there will be like data pipelines at the end of the day are just software. So you of course will want to have like tests, and you'll want to test for everything that you can think of. Um so so that's like usually something, so that's definitely something that you try to do ahead of time, and that's sort of like a simulation. So you can, you might prepare a set of like mock data and then make, or many sets of mock data, and make sure that it does what you want it to do. I think in my experience though, while that is really really valuable and you absolutely should do it, you will still oftentimes have weird cases. And remember, sometimes these weird cases are from things completely unrelated to the data, right? Like maybe there's an extra load on your system and you run out of memory. Like there's a lot of crazy stuff that can happen. So I think you should sort of prepare as best as you can, but also accept that you need to have really good observability there for when it inevitably doesn't work.
Yeah, makes sense. I'm looking at the time, and we do have enough time to at least mention the other topic that you and I briefly chatted about. And I think it's a very important one, but also interesting one. So I think maybe I do want to pick your brain about that a little bit as well. You mentioned that you're also very interested in, on the one hand, thinking a lot about data pipelines lately, but also sort of a second different topic in data science that's also very important, I think, which is making the outputs and whatever things that a data scientists produce make useful for everyone who's maybe not a data scientist, right? Anyone who knows nothing about data science, knows nothing about modeling, machine learning, or anything like that, but could really make good use of what data scientists can produce and come up with. So I just basically wanted to kind of know what you were thinking about in on that front, and is there any kind of types of outputs that you think are particularly useful to many people, or to people who might not be technical or data scientists? Is there a particular, I don't know, way to make things that are typically not useful to everyone, to make it useful to everyone? Kind of all of that. Now I threw 5 questions at you.
Yeah. Well, I think the thing to remember is that like often this isn't always the case, but like typically what you're producing as a data scientist isn't a model, right? A model is just a means to an end. You're trying to produce some insight, right, or drive some business value from a model. There are some companies that sell models, so I guess in that case, their model is their output. But for typically for most of us, it's really about aligning the output of your model to the task at hand. And in my experience, what that often is really means is you really need to understand whoever you're working with to build the model, or maybe building the model for you. You have to really understand their process and like what they're trying to accomplish. And then you have to try to integrate your results like into their process as best as possible. And oftentimes this is through some sort of like presentation layer or a dashboard. So I think sometimes sometimes as data scientists, right, we get very consumed by, okay, what's the latest and greatest like NLP model, and can I squeeze an extra 0.2% out of this, when really the challenge we have to actually driving value is, how do I take this NLP model and actually make it useful to someone who doesn't necessarily know about NLP, or maybe doesn't even know what NLP stands for.
Yeah.
Um, a- and it's almost like product management, right? It's really like thinking about who's my user group, what are they looking for, and oftentimes simple dashboards or really simple ways of displaying sometimes complex information is the most digestible form.
Yeah, yeah. And also, I would add maybe I see a lot communication as being very important there, right? In whatever way, who communicates with who, but where the information comes from the end user, or from, I don't know, the sales team or the whatever team, or whoever will be the one using your product, to the data scientists, right? To understand, what do we need? Should there be a button or not? Do you need this, or is this like, wasted time for us to, yeah, improve that NLP model by a little tweak, when that's not the part we care about or that we're going to be using, right?
No, that's absolutely true. And it kind of starts at the beginning, right? I mean, at least in my experience, it's rare that like someone will approach you, and especially someone who's non-technical, and be like, I want you to train a BERT model on this, right? They're gonna say something more like, hey, like this is like something I've been wrestling with, and like I maybe think that there's something like data sciencey that could be done. But they're not gonna like give you a clear set of instructions on what to do. And so communicating with them about what they're trying to do, what they're achieving, right, actually has to start at the beginning. um, and and that's when you should start working out, well, how do you actually want to consume this at the end of the day, and what are you trying to do? And I think a mistake that I've certainly made, right, is to jump right into it, to say, okay, I understand, let me go mess around in Python for a while, and then I'll surface and tell you what I did. And people, I think, want to be involved in the process, and they definitely want more communication at the beginning.
Yeah, makes sense. Um, does it happen, or has it happened in your experience, that you also, as a data scientist, is not only that you should listen in terms of in that communications and what they might need and what they're asking for, but maybe also listen in the sense of, so that you recognize possible options for a product or a solution when they wouldn't necessarily even approach you, right? To be like, I need something that is going to automate this and that, but where you maybe see some opportunities and things that a data scientist could possibly solve, or come up with a product that would solve it for them without them necessarily kind of recognizing, you could solve my problem. Does that ever
uh
happen?
yeah, it can happen. But I think I think as I mean, I think anyone that works professionally, but especially data science, I think you do have to have a sense of humility right around your expertise and your subject area. I think that the trend that I'm seeing right now is a lot of that I see a lot of things online that are basically saying things like, oh, well, data scientists, they train AI models, they can work in any industry, they can do anything, and they don't need to know anything about the industry. And I think that's like partially true, but you also have to be humble enough to really understand that the people you're working with have a very deep expertise in what they do and in their industry in particular. And I think before you come up with any great ideas, you want to make sure you spend a good amount of time learning from people and really understanding what they're doing and what they're trying to do. And then I think you should maybe propose ideas. I think sometimes if you go in a little too early, you may not have necessarily appreciated the complexities yet, and a lot of problems seem relatively simple on the surface, but as you get into the details, get more complicated. So I think you can absolutely do it, but you should make sure to spend a lot of time listening before you speak.
Absolutely. I think this is such an important tip. And also, you put it so well, and we're out of time, that this is just a kind of like a perfect way, I think, to end our conversation. I couldn't agree with you more. Um, Definitely, yeah, domain knowledge being important. And I would say, even just in general in life, if other people have their own experiences, and also might know a lot, and in particular, if you're around people who might know more about than you in a certain domain or something, definitely good to listen. Just in general, good to listen, I think. um, Zach, thank you so much for joining me today and chatting with me. It was great to pick your brain. I wish we had more time, but maybe you can come back one day and we could talk more.
Yeah, thanks, Anna. I appreciate it.
Great. All right. I can click the button. Actually, no, I won't stop recording, because I'm gonna say hi to you and thank you again and bye to you, and then I'll record the intro and I'll just have it all in one go, or in one file. So I'll do that. I was gonna stop the recording otherwise. Do you see me again?
Yeah, I do. Here, one
Perfect.
second.
Um, Zach, thank you so much. Honestly, I wish we had more time, and then we didn't have to kind of go really fast from one and then through everything, but that's great. As I said, I am gonna give it to Morgan, who's our editor. He's gonna edit it, and sometimes he does it really fast, and sometimes he has stuff, kind of other episodes on his plate, and then by the time he gets to it, it takes a while. But I will make sure that he sends me or just you directly, or both of us together, the version before it goes out.
And just if I could just like sign off on it first, just to for
Yeah.
comfort level, that would be
Yeah, yeah,
awesome.
yeah,
Yeah,
yeah, yeah, yeah. Exactly, exactly. So before it's released, um, he'll send it to both of
awesome,
us. Great.
cool.
Say hi to New York for me. I kind of
I
miss
will
it a
say. I
bit.
will go say hi to the street. Anyway,
Go.
have a
Yeah.
have a great rest of your day, and stay in touch. And
Yeah. Yeah.
thank you very much.
Thank you so much.